Yes, sir.
We will discuss in detail about the science of statistics for data analysis. One quote I would like to share with you that tells us about the significance of research. Anything without research is like shooting an arrow into the air, then looking for the target to catch it with. This quote given by the eminent personality tells us about the great significance of research. And without the application of proper statistical tool, proper statistical technique, we will not be able to conduct genuine, reliable, and valid researches. So we will discuss about the appropriate statistical tools which can be used to analyze data. I divided my presentation into two different parts. First, we will start from the concept of research, basic concept of research, only 2-3 minutes, and we will discuss about the concept of variables. Since after the collection of data, we analyze the data and we collect the data on the basis of different variables. So we should have an idea about the basic concept of variables as well as research. Second part will be the main part of my presentation. That is basic concept of the science of statistics for data analysis. Let's start the story. Concept of research and variables. We know that we all have an idea about the research. Any creation of knowledge is known as a research. But one condition applies as per the eminent scholars, that should be acceptable in the society. Anything that is not acceptable in the society, that cannot be considered as a part of research. And to conduct research, we undergo a process. And this process starts from a problem, and this process ends at a solution. From problem to solution, we do different types of activities. We identify the problem, we formulate objective, we formulate hypothesis, we collect data, we analyze data, and we draw inferences. But we have to do these activities systematically. So in this whole journey that is known as research, we can say that research is a process whereas activities are carried out systematically to find out the solution of any problem. And out of all activities, I will give stress on only one activity today, that is data analysis. Why? We have to draw inferences. We will discuss in detail which type of technique will be applied where. One more point, we should have an idea about that. What is the origin of any problem? We have discussed that this journey, the journey of research, starts from a problem. But what is the origin of any problem? The problem of origin is differentiation, choice. Where there is a choice, there is a problem. Where there is a variety, there is a problem. Where there is a variance, there is a problem. But this variance word is purely from statistics, but now we are talking about research. So one term is there, variable. The origin of any problem is variable. So what do you mean by variable? Variable is a characteristic that has the tendency to change with respect to time, place, individual. In every field, there is a long list of variables, and any researcher, any investigator want to conduct the study by taking different variables. For example, in the field of biomedical researches, doctors, medical professionals, they conduct their studies by taking variables like hemoglobin, myoglobin, leukocytes, neutrophils, basophils, resting heart rate, vital capacity, breath holding capacity. In the field of psychology, there is a long list. The psychologists conduct researches by taking different variables, aggression, anxiety, stress. In management studies, there is a long list of variables. So we should keep in the entirety of our mind that we conduct the origin of any problem is a variable, and on the basis of a variable, we collect data, and after collection, we analyze the data by using proper or appropriate statistical technique or statistical tool. So now, in very brief, we will discuss about the different types of variables. We should have an idea about that also. So after that, we will be able to understand in a proper way about the application of different statistical tools. So different authors described variables in their own way. I will discuss about the two different types of classification, variables and their types. One classification is on the basis of a causal model. If any investigator, if any researcher want to conduct experimental study, this causal model applies. What do you mean by this? As per the causal model, all variables can be classified into three different categories. One is independent variable. I will talk on the basis of a simple hypothetical example. Let's formulate a simple example. Effect of morning walk on blood pressures. I am taking very simple example. Effect of morning walk on investigator. Morning walk on blood pressure. Investigators' interest is to find out the change in blood pressure only due to morning walk. In this hypothetical example, morning walk is considered as a treatment, means independent variable. The treatment is known as independent variable. Next one is dependent variable. In our hypothetical example, effect of morning walk on blood pressure will be considered as a dependent variable. Here, in this example, investigators' interest is to find out the change in dependent variable only due to independent variable. But it never happens. There are several external factors that plays a vital role in bringing the change in dependent variable. In our example, that is blood pressure. Except morning walk, several factors will play a vital role. These are known as confounding variables. And these confounding variables can be classified into two categories. First one is intervening variable. Intervening variable means that these are beyond the control of investigator. These will be considered as our limitations. We cannot control. Only we can minimize the this variance. For example, humidity, climatic conditions. We cannot change the climatic conditions. We cannot change the humidity. We cannot change heredity. Any effect due to heredity, any hereditical effect, any climatical effect simultaneously with the morning walk will be considered as intervening variable. Next one is extraneous variable. Extraneous variable means to a great extent, the investigator, researcher may try to control. Examples are daily routine, food habits. Yes, we can control. So here in this hypothetical example, effect of morning walk on blood pressure, the change in blood pressure only due to morning walk is known as treatment variance in the language of research. Treatment variance, change due to treatment, and treatment is morning walk. Ladies and gentlemen, I am going to speak an important point. Change in dependent variable means change in blood pressure other than independent variable, other than morning walk, is known as error variance. That change due to confounding variables may be intervening, may be extraneous. This is error variance. And our purpose is we have to conduct the study by following the principle of maximization of treatment variance and minimization of error variance. So we have to apply the technique that fulfills this principle, maximization of treatment variance and minimization of error variance. From this sentence, one point is clear. The error variance cannot be eliminated. An investigator may try his or her level best to minimize the error variance. I will discuss about one more classification given by the different researchers. That is on the basis of unit. We can say that on the basis of the unit of measurement, or we can say that on the basis of scaling techniques, or we can say that on the basis of the types of data. If on the basis of unit of measurement or scaling technique, all variables can be classified in only four categories. First one is a nominal scale. In nominal scale, we have to use specific techniques. I will discuss later. Nominal scale, when we collect data in frequency or counts, that will be a discrete series. That will be whole number. Number of males, number of females, number of agree, number of disagree, number of urban, number of rural. We cannot say that number of male is 2.6. Either that will be 2 or 3. That will be a whole number. That is known as a nominal scale. This is subdivided into two, sub-classified into two categories. First one is dichotomous. We know that the word dichom means two, having two ends. Dichotomous. We have two options: gender, smoking, smokers or non-smokers. Polytomous. Polytomous means divided among more than two categories. Example is race, Indian, German, French, Americans. And this polytomous may be of two types. Nominal with order. Suppose if we have three categories: high, medium, low. High, number of high is 5, medium is 6, low is 3. Yes, we can arrange in a order. The polytomous, this category can be arranged in order, maybe in ascending order, maybe in descending order. And another type is nominal without order. Race, I have said race, Indian, Japanese, French. We cannot arrange in order. All will be considered as same in statistics. So we have discussed about one scale of measurement, one type of variable that is known as nominal scale. Second one is an ordinal scale. When we collect data in an order, if it is not possible to measure in a specific numeric value, we may measure in ascending order or a descending order. Example, suppose if I ask you, what is the beauty of your friend? Beauty is a variable. We can measure the beauty. So you cannot say he has 5 centimeter beauty or he has 1 ton beauty. No, you cannot say. You can say he has above average beauty or excellent beauty. If I talk about the pain, suppose you are doing weight training, you are doing exercises and you got injured, you approach doctor asked you, gentleman, what is the severity of pain? Pain is a variable. But that cannot be, pain cannot be measured in a numeric value. Then you cannot say, I have 10 kg pain, 10 kg pain. No, you will express an order. Sir, I have medium pain. That is tolerable. So on the basis of that, doctor will give you the medicine. So these are the examples of ordinal scale. We can measure in an odd only order, maybe ascending order, maybe descending order. Next one is interval scale. Interval scale means having the same intervals in between but has no fixed zero. For example, aggression. Aggression has no fixed zero. You don't know what is the origin of aggression. Next one is ratio scale. Having same intervals in between but has a fixed zero. Height. Yes, we know that starts from a zero. So we have discussed about the two different types of classification of variables on the basis of causal model and on the basis of unit of measurement. So we will discuss about the application of the statistical tools in nominal scale, which technique will be applied, in ordinal scale, which technique will be applied, in interval scale, which technique will be applied, and so on. Now come to the main part. Now my main story starts. Basic concept of the science of statistics for data analysis. We collect data. After the collection of the data, we face a main problem. Which technique will be applied? Which statistical technique will be applied? For the analysis of data, we require statistical techniques. And these statistical techniques are known as inferential statistics. Why these are known as inferential statistics? Since these are used to draw inferences. Ladies and gentlemen, by the application of the statistical techniques, we do inferences, but we forgot there are some limitations of statistics. It is not possible to discuss about the all limitations of statistics in the limited duration of time, but I will discuss about a few. One main limitation is statistical laws are not exact. After the analysis, we get the probable answer. We can't say it's 100% correct. Due to this, there is a concept of the level of significance in scientific studies. You conduct your studies at 0.01 level of significance. It means that you are 99% confident and your significance level is 1%. In social sciences, humanities, management studies, business researches, you conduct your studies at 0.05 level of significance. It means you are 95% confident and your significance level is 5%. All inferential statistics, all statistical techniques are divided into two categories. First one is parametric statistics, another is non-parametric statistics. But we always do a mistake. Directly, we apply parametric statistics, but we cannot apply parametric statistics without fulfilling some assumptions. Some assumptions should be fulfilled before applying the technique which comes under the category of parametric statistics. And these two common assumptions are, first one is the data should be normally distributed, means having maximum concentration of the scores at the center and the frequency tapers at both the ends. If this, if the normal distribution is this, if this assumption is fulfilled, in that case we can apply parametric. Otherwise, we have to apply parallel non-parametric technique. We should keep in our mind. So the first step in front of the researcher should be testing normality. Why? We have to decide whether I have to apply parametric or non-parametric. We will discuss how to test the normal distribution. Practically also I will demonstrate. Next one is, we have discussed about the 4 scales of measurements: nominal scale, ordinal scale, interval scale, ratio scale. In first two scales of measurements, in nominal scale and in ordinal scale, we cannot apply parametric. At least interval or ratio scale is required to apply the techniques that comes under the parametric statistics. On the other hand, non-parametric technique can be applied in any distribution, in normal distribution also, in normal and non-normal also, in any scale of measurement. In any scale of measurement, I mean, in nominal scale we can apply, in ordinal scale we can apply, in interval scale we can apply, and in ratio scale we can apply. But parametric statistics can be applied only in 2 scales of measurements: interval scale and ratio scale. Now when practical part starts, after the collection of data, we have to check the normal distribution. Why? We have to decide whether we have to apply parametric or non-parametric. So how to check the normal distribution? We will discuss in detail. We have 3 options. We have 3 methodologies. We have 3 procedures. By using that, we can test the normality. First one is known as descriptive statistics. Second one is a graphical method. By the help of a graph, the graph is generated by the help of the data. Next one is the formal test. Let's discuss one by one. Let's start with the first, descriptive statistics. After hearing the word descriptive statistics, measures of central tendency and measures of variability comes in front of our mind. Measures of central tendency means mean, median, mode. Measures of variability: range, quartile deviation, mean deviation, standard deviation, skewness, kurtosis. All these measures comes under the category of descriptive statistics. But here, our purpose is to test the normality only. If our purpose is only to test the normality, we do not require all descriptive measures. Out of all descriptive measures, we require only 4 measures. First one is skewness. That measures the symmetricity of the curve, symmetricity of the data. And we require standard error of skewness. We require kurtosis. Kurtosis measures the optimal flatness of the curve, and we require standard error kurtosis. I will show you how to calculate these 4 values: skewness, standard error of skewness, kurtosis, and standard error kurtosis, by using a software SPSS, Statistical Package for Social Science. How to take decision? There are different ways. One simple way is, one thumb rule is, if the value of skewness or kurtosis, ladies and gentlemen, please try to understand. If the value of skewness and kurtosis comes under the category, comes in the range of -1 to 1, it means data is normally distributed, apply parametric, otherwise apply non-parametric technique. Second way, if the value of skewness is less than standard error of skewness, or if the value of kurtosis is less than standard error of kurtosis, in that case also, yes, data is normally distributed. Second one is a graphical method. This graphical method is known as QQ plot. You know that in graph we have an x-axis, we have y-axis. In this graph, one standard line is generated. How to take decision? If all the scores are scattered near to the standard line, it means data is normally distributed. Otherwise, data is non-normally distributed. I will show you. Next one is a formal test. These are established to test the normality only. There is a long list of normal tests. We require only one to test the normality. Yeah, famous formal tests are KST, Kolmogorov-Smirnov test, SWT, Shapiro-Wilk test, ADT, Anderson-Darling test, RJT, Ryan-Joyner test. Out of these four tests, out of these four formal tests which are used to test the normality, SPSS provides us the facility of first two. That is KST, Kolmogorov-Smirnov test, and SWT, Shapiro-Wilk test. Ladies and gentlemen, I am going to discuss about the one more important point. Testing normality depends on the sample size. In every sample size, the methodology will not be same. And we have the concept of sample size. If we conduct any study by taking less than 30 scores, data or sample, that is considered as a small sample. If we conduct any study by taking 30 and above, that is considered as a large sample. No, but this concept has been changed by the statisticians recently. Instead of two sample sizes, now there is a concept of three sample sizes. First one is a small sample. The concept of small sample is same. If we conduct any study by taking less than 30, that will be considered as a small sample. If we conduct any study by taking in between 30 to 100 units, that will be considered as a moderate sample size. This range is added. The next one is a large sample. If we conduct any study by taking more than 100 subjects, that will be considered as a large sample. As I have said earlier, that testing normality depends on sample size. It means the procedure to test the normality for small sample will be different. The methodology to test the moderate sample, normality of moderate sample size will be different. And the methodology to test the normality of large sample size will be different. Let's discuss one by one. Let's start with the first, testing normality of small sample size. How to test? Answer is, there is no need to test. Always assume that data is non-normal and apply non-parametric, especially in social science, humanities, business researches, management researches. But if you conduct your study in a controlled condition, especially experimental studies, in that case, you can test the normality. Now, second is how to test the normality of moderate sample size in between the 30 to 100. How many methods we have? Three. Which one? Descriptive, graphical, formal. Which method will be applied? Or all methods will be applied? It is advised by the scholars to apply all three methods. First, apply formal test. What will be the answer? Answer will be yes or no. The formal test will tell us if data is normal or non-normal. If this formal test shows data is non-normal, accept the results and apply non-parametric instead of parametric. If as per the result of the formal test, data is normal, 100% do not rely on this. Cross test by using remaining two methods. Remaining two methods are descriptive statistics and graphical method. Next one is how to test the normality of large sample. Apply formal test. If the test says yes, data is normal, accept the results. Why we are accepting results here? Since these formal tests are very accurate in case of large sample, and these are very sensitive in case of moderate sample size. If as per the result of formal test, data is non-normal in case of large sample, then cross test, identify the exception score, identify the outliers, remove that score. That will not be considered as unethical issue. Now, I will proceed to the practical part, how to test the normality. Uh, I require assistance from any participant who will assist or who will cooperate me. Uh, please tell me. You should not hesitate. Any participant. Anyone participant, please unmute your mic.
Yes, sir.
Okay. Gentlemen, how many techniques are available to test the normality? Three. Agree? Three.
Yes.
Descriptive, graphical, and formal. Is it okay? Now we are going to discuss about how we have to generate output by using SPSS. Now, on how many subjects, gentlemen, on how many subjects you want to conduct the study? Suppose on 20, 30, 10, 15, it will be easy for me to communicate.
Sir, 30.
30, okay, 30. That comes under the category of, that comes under the category of?
Small.
No, less than 30 considered as small. 30 and
It comes under moderate.
Moderate sample size. Yani you want to conduct a study by taking moderate sample size, by taking 30 units, that comes under the category of moderate sample size. See, here there is a data view. See, data view. Is it visible?
Yes, sir.
In data view, this spreadsheet is same. Do you have an idea about SPSS? Yes or no?
No, sir.
No. This is similar to that Excel sheet. You are seeing more or less that is similar. But in Excel sheet, we have only one spreadsheet. We can enter the data. We can enter the characters also, alphabets also. But in SPSS, we have two views. See this data view. In data view, we have to enter the scores. In variable view, we can give the label. We can enter the characters. Is it okay?
Yes, sir.
And you have said you want to conduct the studies by taking 30 subjects. Give me the name of any variable. Any variable from your own field. On height, on weight, on speed, on sale.
Sir, on price index of stocks.
On price index of
Stock market. Share of a price of a shares.
Price of share. So please tell me the 30 scores. The score. You are taking the different institutions, companies, or sectors.
Yes, sir. Different institutions.
Different institutions. You have 30 institutions. Yes. The score for the first is, suppose I am 34, 56, 45. Is it okay?
Yes, sir.
These are hypothetical data. And you want to conduct study by taking only
30.
30 institutions. You want to decide whether you have to apply parametric on or non-parametric. For that, you have to test the normality.
Yes, sir.
So go to variable view. What is write down the name of the variable? What is the name of the variable? You have said earlier.
Yes, sir.
Which index?
Share prices.
Okay, any index. Okay, any index. Okay, how to test the normality? Go to analyze. Go to descriptive statistics. After that, go to explore. Click on explore and bring this variable, your variable named index. Bring this variable in the dependent list. Now go to plots and click on plots. Gentlemen, where is my cursor? Arrow. Where is my arrow?
Normality plots with test.
Yes, opt for. Select this normality plot with test. Continue. Click on OK. Result will be in front of you. Result will be in front of you.
Got it, sir.
See, where is my this arrow? Index.
Index
This is the name of the variable. How many units you have taken?
30.
30. All 100% data are valid.
Yes,
No
sir.
one is missing. See, the mean value is 48. This is a 9. But we require only 4 values. Where is my this arrow? Cursor?
Interquartile range.
No.
Skewness
Skewness. The value of skewness is
0.344.
yes. This is in acceptable range. And what is the value of kurtosis?
Minus 0.173.
This is also in acceptable range. Yes, you can apply parametric. Now, see, I am making this data non-normal. Suppose on serial number 7, I am changing this score. The score is 556. Exceptional score, exceptional, outlier.
Yes, sir.
I hope you will be agree with my statement. Ki this 7th number score distorted entire distribution, all data. Is it okay?
Yes, sir.
Now, again, I am repeating. Analyze, descriptive, explore, click on OK. Now, gentlemen, see the value of
Skewness is 5.398.
if it's higher than 1.
Yes, sir.
Kyoto's is 29, severely skewed. We cannot apply parametric. Okay. Now, we will discuss about remaining methods. See, go to now. I corrected that score. Again, click on analyze, descriptive statistics, explore, click on OK. Next method is one is descriptive. Next one is, I hope you have written
Graphical method.
graphical method. This graphical method is known as QQ plot.
QQ plots.
Plots.
See this QQ plot. See, a standard line is generated and all the scores should be scattered near to this line. If all the scores are more or less, all the scores are near to this line. So this shows that data is normal. And next one is a formal test. See, formal test. This is Kolmogorov Smirnov test and Shaparovilk test. Now, again, 7th score, I am going to analyze, descriptive, explore, click on OK. See this QQ plot. See this QQ plot. And please give your comment. Gentlemen, it means the score is scattered away from this standard line.
Yes, sir.
I have said earlier that if the scores are scattered near to the line, standard line, the data is normal. If the scores are scattered away from the standard line, data is non-normal. In this case, the score is scattered away from the center line. Is it okay?
No, sir.
So, see, this standard line is generated. Is it okay?
Yes.
These dots shows the scores. If all the scores are scattered near to this line, see this single score is scattered away from this standard line. We will conclude that data is non-normal. Is it okay?
Yes, sir. Yes.
Now, how to identify? Gentlemen, in that case, we should remove this score. Instead of 30 scores, we should conduct our study by taking only 29 individuals. So how to identify? This can be identified by the help of the box plot. And box plot is present. See what is written here?
7.
7. It means, and see the shape of the box plot. It's not appropriate. So now without saving, I am deleting and I am removing this 7th score. Now on how many subjects we are going to conduct the study?
29.
29. Again, see the results. Click on OK. Now see the shape of the box plot. Gentlemen, there is no outlier. It's perfect. Shape is perfect. Is it okay?
Yes, sir.
Yes, sir.
Now we have discussed how to test the normality. I am not testing you for my satisfaction. I am asking a question: why we tested normality? Since we have to decide.
To apply the statistical prediction, parametric or non-parametric.
Yes, we have to decide whether good. We have to decide whether we have to apply parametric or non-parametric. If data is normally distributed, we have to apply parametric. If the data is non-normally distributed, we have to apply non-parametric. Okay. Now, next part. That is the main part. It will be of a great interest. We are discussing about the statistical techniques. And we divided all statistical techniques into two parts, parametric and non-parametric. And we can divide parametric to understand in a proper way in comparative and relationship. Ladies and gentlemen, the smallest comparison is possible between the two groups. So we will discuss about the techniques which are used to compare two groups. We will discuss about the techniques if the time permits. Comparison is possible among more than two groups and by the help of covariate also. Same as comparison, relationship is possible between two variables. Relationship between height and weight, relationship between anxiety and stress, relationship between risk of cancer and lifestyle. And we can establish the relationship between more than two variables. And if we want to quantify the relationship, we have to apply regression. So in today's lecture, we will discuss about only first category, comparison between two groups. If you want to conduct any study and if your study is based on the comparison of two groups, which technique will be applied, we will discuss in detail and practically I will demonstrate by hypothetical example. Ladies and gentlemen, the technique which is used to compare two groups is known as t-test. T-test is a statistical technique used to compare two groups. But there are three different types of t-tests. The first t-test is known as independent t-test. Independent t-test. Different authors described this independent t-test by different names. This independent t-test is also known as student t-test. This independent t-test is also known as a simple t-test. This independent t-test is also known as unpaired t-test. Again, I repeat, this is known by 4 different names: independent t-test, simple t-test, student t-test, or unpaired t-test. This technique is used to compare 2 independent groups. For example, let's discuss with the hypothesis. Let's formulate a title, and the title of a research study: comparison of production of wheat in 2 different districts of Chhattisgarh. And you have taken 2 districts, Raipur and Bilaspur. Suppose we can simplify this: comparison of aggression between males and females. Let's discuss about a simple example: comparison of aggression between males and females. You have 2 groups, both the groups are equal, maybe unequal. Suppose you are taking 30 males and 13 females, and you measured their aggression, and by the help of independent t-test, you can find out the significant difference, whether the males are aggressive in nature or females are more aggressive in nature, or both possesses the same level of aggression. Comparison of the immunity between males and females. Comparison of the sales of the companies of Chhattisgarh or Maharashtra. If you want to compare 2 independent groups, in that case, you have to apply independent t-test. Again, I repeat, independent t-test is a statistical technique used to find out the significant difference between the means of 2 independent samples. And this technique can be applied by taking equal sample size also or unequal sample size also. You can take 30, 30, 100, 100, 200, 200. You can take 30, 40, 40, 50. It is not necessary to take same number of subjects in both the groups. And please try to remember, I will demonstrate by using SPSS also. Our hypothetical example, our hypothetical title for independent t-test is comparison of aggression between males and females. Next one is dependent t-test. As I have said, independent t-test. The independent t-test is known by 4 different names, same as independent t-test. This dependent t-test is known by 4 different names. Different authors described in different ways. This dependent t-test is also known as correlated t-test. This dependent t-test is also known as repeated measure t-test. This dependent t-test is also known as paired t-test. Again, I repeat, dependent t-test, correlated t-test, repeated measure t-test, paired t-test. This is known by 4 different names. So we should not confuse. What was our hypothetical title for independent t-test? That was comparison of aggression between male and female. And what will be the title of dependent t-test? Hypothetical title may be, we have discussed about that, effect of morning walk on blood pressure. We collect the data for 30 subjects in the form of a pre-test. And suppose you have given 30 days of morning walk, and after that you will collect the data of post-test. It means in independent t-test, we have 2 columns, but both the columns are independent, male, female. In this, we have 2 columns, but these are 2 different observations of the same group in the form of a pre or post. It means independent t-test is used to conduct survey studies, comparative survey, and dependent t-test is used to conduct experimental studies. And our hypothetical example for independent t-test is comparison of aggression for males and between males and females, and for dependent t-test is effect of morning walk on blood pressure, comparison between pre and post. So I will discuss about one more t-test, the last t-test, one sample t-test. This is known by the only one name, that is one sample t-test. One sample t-test is used to compare a group with a single value. Comparison Comparison of the production of the 10 companies of Chhattisgarh with the target fixed by the government. Comparison of the aggression of the females of Chhattisgarh with the aggression of Brahmkumari Shivani. We can compare with a group with a specified constant. We can compare a group with a single value. We can compare a group with a norm. We can compare a group with a target. On one side, we have a group. On one side, we have single value. Let's discuss about these three. I will demonstrate. Gentlemen, please unmute your mic. What was the title of our independent test? What was our title for independent test?
Significant variance comparison.
Comparison between the aggression of males and females. Madam, how many groups you are having? Two, male and female. On how many males and on how many females you are going to conduct the study? Please tell me.
30-30.
30-30. Good. So I am entering the scores. Gentlemen, the total number of scores are
30.
60.
Yes, sir. Total 60.
60. It means, but please keep in your mind, all the scores will be entered in the single column. Suppose these first 30 scores are for male. Is it okay?
Yes, sir.
And next 30 scores are for
Female.
female. We have to enter in a single column. In front of this, in front of the first 30 scores, since you have said the first 30 scores are for males, so you can give any label, any name. Suppose one stands for male
Yes, sir.
and two stands for
Female.
female. Yes. Okay. Go to variable view. We have used two columns. In the first column, we have all the scores of aggression.
Aggression.
In the second column, we have group or gender.
Yes, sir.
And you are going to conduct study on two genders. In front of the gender, go to values, see value, click on this, write down one in value, and one means
Male.
males, write down the males. Add this for two females. Add this. Okay, now the data entry is complete. Data entry is complete. Now, how to apply independent t-test? Go to analyze, go to compare means, go to independent sample t-test, bring aggression in the test variable and gender in the grouping variable and define the groups. And we have two groups, 1 and 2. Continue, click on OK. Gentlemen, see, where is my this cursor?
Aggression.
Aggression. How many males we are having?
30.
Female 30. And for males, mean of the
6.6667.
and for females
6.8667.
by seeing the mean, it seems that females possesses the higher level of aggression, but
Yes.
we have to conclude on the basis of this t-test. T value, see what is the value of t,
Minus 0.909.
and this is a significance value is
0.367.
If this value is less than 0.05, in that case, we will say, yes, there is significant difference. In this, since this value is not found significant, males and females both possesses the same level of aggression. There is no significant difference between the aggression level of males and females. Is it clear?
Yes, sir.
And now we will discuss about the next technique. Next technique is
Dependent test.
not dependent test. Dependent t-test, no dependent test.
Yes, sir. Dependent. Sorry, dependent t-test.
Dependent t-test. What was our example? Effect of morning walk on blood pressure.
Yes, sir. Before and after.
Pre and post.
Yes, sir. Pre and post.
For how many days you have given the treatment of morning walk? Suppose
30 days.
30 days, and after 30 days you will collect the data for post test. On how many subjects you conducted the study? 10, 20, 30. You can take any subject,
Yes.
any number of subjects. Suppose you have to identify, you have to decide. Gentlemen, you decided that you conducted your study by taking 30 males and 30 females. You conducted your study on 60 subjects. We have discussed during the application of independent test. Now decide on how many subjects you want to conduct the study.
So on 20.
20. Good. On 20. Now, first we have to take the score of pre-test.
Pre-test.
Yes.
Before.
Yes. This is the blood pressure score of the pre-test. Since you have 20 subjects, you collected the pre-test. This is the blood pressure of the pre-test. Is it okay? Now, after this, you have given the treatment of morning for, you have said for how many days?
20 days.
20 days. After 20 days, then what you will do?
Again collect for after.
Post test. Yes.
Yes, sir.
Now I am entering the data for post test. Yes. Good. In independent t-test, in how many columns we entered all the scores? Single.
Yes,
We
sir.
entered in a single column for males and females. And in this, in how many columns we are entering the score?
Double column. 2 columns.
Oh, yes. In independent t-test, we have to enter all the scores in the single column, but independent t-test, we have to enter the score separately for pre and post. Is it okay?
Yes, sir. So that's why they are dependent t-test.
Yes. But in independent t-test, we have given the label. 1 stands for male, 2 stands for female. Here, there is no need. Since we entered the scores separately, there is no need to give the label.
Yes, sir.
In the first column, tell me what I have to write. Pre.
Pre.
With confidence you can.
Yes, sir. Pre.
In second.
Post.
Yes, post. Data entry is complete. We want to compare pre and post. If the difference exists, in that case, yes, you can say that after morning walk, blood pressure decreases or increases. We don't know. Go to analyze. Go to compare means. See this paired sample t-test. Click on this paired sample t-test. Bring this pre and post, make a pair. Click on OK. See, we are comparing pre and post. What is the mean for pre?
87.6500.
For post?
86.3500.
Yes. And see, the t-value is?
4.212.
And the significance value is?
0.00.
and this value is less than 0.05. Since this is 0.000 less than 0.05, it is concluded that since this value is less than 0.05, there is a significant difference between the pre and post. Means after morning walk, the blood pressure reduces.
Yes, sir.
The blood, the morning walk can be considered as a treatment to cure blood pressure. Is it okay?
Yes.
Now, we will discuss, if the time permits us, can we discuss about one more technique that is known as one sample t test?
Yes, sir.
Yes. What was the title?
One side the whole group and another side the single lady.
Yes. It means what is the name of your course? You are doing a course now. In this, you are a
Yes, sir.
participant of a course. What's the name of the course?
Data analysis and applied science.
Course on data analysis. ठीक है.
Yes.
Let's formulate title. Comparison of the aggression of the females of data analysis course with the aggression of Brahmkumari Shivani. Suppose all females of this group are impressed with Brahmkumari Shivani. They want to compare their aggression with the Brahmkumari Shivani. And how many female participants are there? Suppose
40.
no, it will be difficult to type.
So 15.
15. Suppose total 15 females are there. All 15 females want to compare their aggression with aggression of Brahmkumari Shivani. Is it okay?
Yes, sir.
It means we are going to about a technique, one sample t test that is used to compare a group with a single
Single one.
value. Good. Now see, I am clearing these. On how many females, gentlemen, you want to conduct the study?
15.
15, not 50, 15.
Yes, sir. 15.
Yes. This is the aggression score of the aggression of is it okay?
Yes, sir.
And this is the aggression of data analysis course. Is it okay?
Yes, sir.
And you measured the aggression of the Brahmkumari Shivani also. What is the level of her aggression? Suppose
65.
65. Okay, 65. It means go to analyze, go to compare means see one sample t test, bring this in the and test values 65.
Yes, sir.
We are comparing all scores with a single value. Click on OK. Yes. Significant. It means Brahmkumari Shivani possesses a very low level of aggression in comparison to the females of this data analysis course. Is it okay?
Yes, sir.
So we have discussed about the three different simple techniques which are used to compare two different groups. One is independent t-test, second one is dependent t-test, third one is one sample
One
t-test.
sample t-test.
Now your questions are invited.
Sir, can you show me where you put the 65 aggression? In last one
Yes.
test.
Sure. Is it visible?
Yes, sir.
Go to analyze, go to compare means, go to one sample t-test, see this test value. Is it visible?
Yes, sir. Yes, sir. Okay, sir. Thank you.
You can write your questions in the chat box also. If you have questions. No question. I think this class is for only 1 hour duration.
Yes, sir.
Yes, sir.
Sir, actually the time is for 5:30 to 6:30. And if there are any questions, then we can take up in 1 or 2 minutes. Otherwise, we have another session tomorrow, sir.
Yes, yes. I will be with you for 1 hour tomorrow also.
Yes,
Uh,
sir. So
One question.
if there is no question, then we can.
How we practice from ourselves. Yes, Nitinji, you can download SPSS, trial version of SPSS that is free of cost. You can practice on that also.
Thank you, sir.
So can we start again tomorrow, sir? Thank you, sir. Thank you for the today's session. So participants, we can join back tomorrow. Tomorrow again we'll be having sir session. So thank you everyone.